Hi everyone, and today I'll be talking to you about the lovely, exciting world of water solubility. In this presentation, I'll be talking to you about key terms, which will definitely come up a lot when talking about the water topic in general, especially in this part of the topic. And then I'll talk to you about different exam questions, what they might ask, sorry, and how to answer those questions, especially when it comes to solubility of different stuff. And I'll go through all this terminology in a second. And when it comes to all of this, and then I'll talk about the solubility curve, which I will talk about, so don't worry. So first, let's look at some key terms which will help you understand the topic in more depth. So we have the solvent, which is the liquid used to dissolve the solid, and that solid, after being dissolved in the liquid, is called a solution. Now, the solid is typically called a solute, and I'll give a good example for that actually. Say you have some water and you add sugar to it. The water would then be the solvent and the sugar would be the solute, and then that sugary water stuff, which won't be tasting too nice, would be the solution. Soluble is the ability to dissolve in a solvent, so the ability the solute has to dissolve in a solvent, so how well the sugar will dissolve in water, let's say. And then saturated, or a saturated solution, is a solution in which no more of the solvent of the solute will dissolve. That's a bit of a fancy term, so I'll just try and simplify it so everyone can understand it. So say if you had a lot of sugar, you added it to some water, you keep stirring, and no more sugar is being dissolved, or no more sugar is disappearing, I say using air quotes. That then would be a saturated solution because no more sugar can dissolve. The way we measure solubility is by using the method on the left, and that is typically used with water and measuring the solubility of different things in water because of different properties. I won't go into that now. You'll learn more about that in the future, but water is quite good at dissolving certain things. So if we look at the method, we can see some of the terminology that we learned in the first slide coming up. So if we go through the method, it's quite simple. If COVID wasn't a thing, I'd be showing you the experiment. It's not a hard one. It's quite simple. It's pretty much just adding stuff to water and then dissolving it off and then measuring the mass. That's a simplified version of it. And then that's how we will work out the solubility by using a bunch of weird formula stuff. The higher the solubility, the more soluble it is in water. So that just means how good it is dissolving in water, pretty much. And these were all used in 100 centimeter cubed or 100 milliliters, depends on what you'd rather use. From the results that we gathered, that I had sodium chloride was the most soluble and lead iodide is the least soluble. But there are certain factors which could affect solubility, so some things which can increase the solubility. And as we go to the next slide, sorry, I just realized I read that wrong. Lead nitride was the most soluble, and yeah, lead iodide was the least soluble. But as we go to the next slide, we can see that as the temperature increases, the solids or the solutes become more soluble. So as you can see, we work this out where lead nitride starts off of 54.3 degrees Celsius, not degrees Celsius, 54.3 solubility and increases all the way to 72.1. As you can see with sodium chloride, there doesn't seem to be much increase, but there seems to be a lot of increase in potassium nitride and a lot of increase in lead nitride. Now, what do we do with these results? We put them on a lovely graph and then we can talk about them. Makes it much easier to talk about the results. Some of the questions they might ask, they might give you a graph and ask you to talk about it, or they might ask you to put some results on a graph and talk about them. So one question they might ask is, which one is more soluble? As you can see, typically by that, they might ask which one's more soluble at a specific temperature, or they might ask which one is more soluble at the highest temperature. As you can see, the potassium nitrate is the highest, even if it did reach 100. You could follow the graph up. Lead nitride would stay pretty still, and sodium chloride doesn't necessarily change all that much. So the answer to that would be potassium nitride. Then a question might ask which one increases with temperature, because obviously not every solute can increase solubility does increase with temperature. But we can see the two major ones. That's quite an easy one. Whichever ones point up with the temperature, potassium nitride and lead nitride. Now they might also, like I said, ask for a specific temperature, which doesn't necessarily mean more soluble. It just means more soluble at a specific temperature. Lead nitride's that, because if you go to 30 degrees, go to whichever one's the highest solubility, we can see it's lead nitride, the green one. Now, which one increases the most? This one is quite easy to work out as soon as you know what you're looking for. So it's which one has the highest slope, which one's the steepest slope, the more horizontal. Vertical. Yeah, the more vertical, sorry. It's been a while since I had to sort out that stuff. But yeah, which one is the most vertical? Which one points up the most? And as we can see, it is our lovely purple friend who's always seems to be the answer to everything because it's very easy to talk about. Now I've got some, at the end of this presentation, there'll be workshops, there'll be questions for you to do on them. And hopefully this presentation will help you answer any questions. If not, I'm very happy to help. There's also some good resources out there. Like if you look at the bottom of the page, we've got some BBC Bite Size, we've got some Grade Gorillas. They're very good for certain questions. So yeah, I definitely advise to go off and look at your own, look for some resources, but I'd be very careful as to where you look, just in case, you know, I know things tend to be a bit screwed up, but everything on this presentation should help. And all I can say is good luck, and I'm sure you'll do great in the questions.